undergraduate and graduate level courses. By trade, Dr. Burgett is a general contractor and has spent many years teaching online courses for the trade unions. His primary area of research is in applied drone technology and has worked extensively with South Carolina DOT. His research focuses on applied UAS technology and drone certification. He was named Clemson University's 2018 Master Teacher, the university's highest teaching honor. He serves on the board of directors for the South Carolina Interagency Drone Users Consortium, and it is the state's only 501c3 nonprofit drone association exclusive to South Carolina government agencies. Let's welcome Dr. Drone.
All right. So yeah, the Dr. Drone thing started out as like a kind of a dig, because that was really like my passion, but then I put it on my license plate and really leaned into it a little bit. And having that on your license plate is like the best credential, because whenever you're doing flights, if law enforcement ever want to like check you out, make sure you're doing okay. If you've got that on your license plate, then surely you've got all the rest of the stuff covered. So, all right, let me see if I can figure this control. Oh, there we go. Okay, so what I'm going to kind of talk about today is drone assessment, a little bit different than some of the other speakers here, and that's kind of the space that I work in. As you guys all know, in order to use a UAS commercially, you got to get that Part 107 exam, outside the COAs and that kind of stuff. And the test itself, again, I won't go into everything that's included with that. I know you guys are very familiar with that, but it is a knowledge test. And to my knowledge, it is the only certification or license that you can go and take and be fully credentialed without ever doing the thing that you are now licensed or credentialed to do. So the space I'm in is on the other side of that. So again, you can be 100% legal, take that test, go out, and then smash right into it, right? So just one of those few things. And that's not casting shade on, any of the reasons or the things about the Part 107. There's very good reasons why it was implemented the way that it was. But the reality is it's just a knowledge test. There's that big piece. So the way I think of flight proficiency, and this isn't just me, this is backed up and really endorsed by some of the standards, AASHTO standards and whatnot, is that flight proficiency really is the intersection of three main components. One being general knowledge, and the ASTM standards by name call out the Part 107 and kind of addresses that, all right? So the rules and the regulations, that sort of thing. And then field operations. Those are things like being able to go out to a site, know your checklist, look for risk, crew resource management, all the operational type things to be able to conduct a mission successfully. And then there's the focus really of where I'm at, and kind of the subject of what we'll be talking about now is that's aircraft control. So stick movements, moving your thumbs, navigating the drone to a specific GPS or three-dimensional coordinate consistently and efficiently every time. So that's kind of where my space is, and the study that we're working on in Clemson and what I'll kind of elaborate on here. So while the FAA doesn't have a certification or a test that tests the flight skills or the stick motions, the federal government through NIST does. NIST is a national lab under the Department of Commerce. If you've ever heard of the atomic clock, that's them, okay? So they do lots of different things, but one of their labs is their robotics lab, and they've developed this test. If you've ever gone out for a workshop or whatnot and seen 5 gallons or 2-gallon buckets that are on little stands, that's them. NIST has several different test suites. They have probably the most common is what's called the open lane, and I'll elaborate on that a little bit more, but that's what's shown here. They've got what's called the BPERP. That's an acronym for the Basic Pilot Proficiency Evaluation for Remote Pilots, obstructed lane, and others. They have several different suites of tests that, again, certify or assess a pilot's ability to navigate in the environment, near obstructions, away from obstruction, that sort of thing. Now, NIST provides the test. They tell you how to grade it, but they don't provide a certification, nor do they provide any kind of recommendations that say, in order for your organization to say these pilots are quote unquote proficient, they meet these scoring or testing standards. They leave that to whatever agency is adopting it to make those calls, all right? So it's a tough thing to be able to say, okay, your pilots are this good and that's good enough, right? Because if you think about it, how do we know that you're good enough to drive a car, right? Everyone's got different skills. You might have a NASCAR driver have a certain level of driving skills. My 15-year-old daughter has a certain level of driving skills, right? Both may be equally terrifying to ride shotgun, but, they both are legally allowed to be on the road. So, it's somewhat subjective in terms of what the level needs to be. So if you're not familiar with the test, I'm going to do kind of a quick little introduction, but it's these bucket stands, and the buckets are either pointed straight up or at 45-degree angles, and a proctor of the exam will tell the pilot who's taking the test to maintain S distance. Typically it's 10 feet away from a target, and then S distance, again, 10 feet up. At these different points. And if you're 10 feet away and 10 feet up, if you angle your camera down at 45 degrees, you should be staring down, straight down into the throat of these buckets. If you're a little bit too far to the left, you're a little too far to the right, up or down, then the walls of the buckets will obstruct your view of the target. And if you're not able to see that complete green ring at the base of the target, when you take a picture of it, you would not be awarded that point. So the in-person test is great. I mean, it's a well-constructed, it's easy to administer, it's got a lot of strengths to it. But like any kind of flight assessment out in the field, there's some limitations to it. One, for you to have these apparatuses, there's a cost to build them, which isn't a huge barrier, but a couple $100 a test lane. You got to store them. In my lab, we have a couple of Connexes, so it works out well, but not everyone has that kind of real estate and space to be able to store this stuff. It can be inconvenience to administer the exam. You schedule a time to do it, and then it's raining, or you schedule time to do it, they get sick, they're not able to do it. It's just, you got to set it all up, you got to transport it someplace. So there's labor involved in setting up the exam. It's labor intensive to administer. Again, you have the pilot's time to take the test. You have to have a proctor grade the test, stand with them, call out the instructions, so there's time there. If you're using this as a test, the environmental conditions aren't standardized, so one day you got two pilots, one day takes it on a nice, clear, sunny day, and they barely pass, but they get their license. The next day, an equally skillful pilot takes it, but it's windy, and they can't pass it. And to use the vernacular that I hear in class a lot, that's not fair, right? So you've got different environmental conditions that can impact it. I won't go into a lot of the details here about the difficulties in the S distance, but one thing I'll just kind of point out for you guys that are administering, one limitation that turned out to be not a very big deal, but in this test, if you're 10 feet away and 10 feet up, then you can see down the throat of that bucket. But what happens if you are wildly out of position? You're like 50 feet away and 50 feet up. You're wildly out of position, but your ratio's right, so you can still look down the throat of that bucket. So that's kind of a limitation with the test. We did a bunch of studies on this, and even though that's a limitation, it can really be managed well in the field if proctors are aware of it. So it's not a huge deal, and again, it's not casting shade at the test at all, as long as you're aware of it, but it is in fact a limitation. So what was our solution to this? With again, all the limitations of having an in-person test, it's kind of costly to build, costly to administer, inconsistencies with a standardized test. Well, our solution for that was to bring the actual test in the real world and bring it into the virtual world. So through the support of a STIC incentive grant, Clemson, SCDOT, and a private software company partnered up, and we built a simulator. We put the NIST test into the virtual world, and it's been working very, very well. If you have the simulator, there's some advantages to it. So those costs that we were talking about in terms of building in-person apparatuses and storing them, those go away. The only cost that you have for storage is literally just your hard drive space. No cost to build, no cost to store, easy to administer. It records what is being done, so you don't have to schedule time to do it, drive all this stuff out, set it all up. Literally, if you've got a meeting in 20 minutes and you want to get 15 minutes of stick time in, you just load up the sim and you go fly. You can do the test. You can get a little bit of stick time in there to keep those muscle memory going and move things forward. That issue I mentioned about standardized S distances is not an issue. If you are wildly out of position, again, that's just programming that we can, if you're 50 feet away and 50 feet up, but can still see the target, we're not going to award you that point in the sim because, again, we know exactly where you're at in that virtual environment. So there's a lot of advantages into using a simulator. The best part is if you got a .dot or a DOT in your email, it's free. Part of that stick incentive funding was to provide all state DOTs 10 licenses to the software. So it's available to you guys at no cost. I've got my contact information here. I have it at the end of this presentation as well. So if you want access to this simulator, just send me an email and it is yours. I will facilitate that. So, and it's been working very well. With that all said, the simulator's great, assuming it works, right? Like any kind of software, it's great, assuming it works. And I don't necessarily mean like it crashes on you or it doesn't work on a computer system. What I mean by that is if the drones that we have programmed in there in our library of drones, we have 14 or so, is the physics that we have put into the simulator, does that match the reality? If we fly a Mavic in the sim, does it have the same responsiveness and characteristics as a Mavic in the real world? So we had to do a boatload of testing. And what we did is we got a great facility on Clemson campus with beautiful AstroTurf soccer fields. We set up a bunch of NIST test lanes out there. We invited a whole bunch of novice pilots wasn't exclusive to the DOT community, but it was government agencies across the state, students, faculty, a whole bunch of people come in. Take the test in the real world on our campus, and then immediately go into the lab and then do the simulator. And then we compared scores. And we were a little bit sweating bullets there because if they weren't the same, that really, kind of messes things up. But fortunately, everything really worked out well. At a very high confidence level, we saw the scores and the times of the in-person NIST test versus a simulator in test were highly correlated. So that went well. The next thing we want to take a look at is, okay, we got this simulator. We can say that at least for basic flight maneuvers, and again, there's some nuances when you get to complicated things, but at least for basic flight maneuvers, straight up stick control, when you want to move forward and your drone goes up, that's when you know you're using the wrong hand type of thing. But are all 5 of the maneuvers in that open lane suite necessary? So that open lane test composed of 5 maneuvers, and you can see them here on the screen, but all they basically are 20 different points that are earned for each one of these maneuvers, man 1 through man 5. Are all those necessary? So what we did is, again, we had a whole bunch of people take the test, and we compared their scores with how they performed for all of them, and said, well, can we use statistics to say if you just did one of these maneuvers, we can say with a high correlation that you don't need to do the other 4. That one is good enough. Or if we just do 2 of them, that's as a high p-value, and we can say if you did those 2, then that's an accurate predictor of your stick skills. So we were looking at this, but and we have the pure data science, in one mind, but the other side, we are, if you're familiar with NIST, they've been big advocates of a modification or a version of the open lane test that they call the BPERP. BPERP, of course, is an acronym for the Basic Piloting Evaluation for Remote Pilots. I think I got that acronym right. But it's a modified test, and basically it consists of just man 1 and man 2. Man 1 has 20 points if possible, man 2 has 20 points, so it's a 40-point test. It's a kind of a quick, easy assessment for basic flight skills. They have kind of an unofficial partnership, NIST does, with APSA, not to throw another acronym at you. APSA is the Airborne Public Safety Association. They're very big in the law enforcement space. They have, to my knowledge, the only nationally recognized flight proficiency assessment. So they're big in that space, and they have adopted the BPERP exam. So part of us, there's a natural gravity to, if we can get the data to support using their BPERP, then that as a good metric for flight proficiency, we wanted to kind of go that route. And what we found is it was pretty close. Again, There's an expression that I love. There's three types of lies: lies, damn lies, and statistics. And I'm not a statistician. Them and lawyers will turn me up and down one way or the other. But we hired your services, and any of the maneuvers. If you take total flight proficiency, all the times and scores of all 5 of them, and a perfect correlation is 1, well, we took each one of the individual tests and said, okay, which one of these best correlates? And it ranged from a 0.73 to 0.91 correlation, so not bad, really. So then we did well, what if we took 2 of the maneuvers? If we just pick all 2 of these and just pick 2, how correlated were they to the overall flight proficiency that we saw with all 5 of them? And it ranged between, again, 0.91, 0.75, 0.95, so still pretty highly correlated to the overall times and scores when you did all of them. So we've been using the BPERP. It wasn't the best of the 2 combinations, but it did a really good job of overall assessment. So that's what we were kind of using for all of our purposes. So again, going back to the whole aircraft control, right? So we want to develop some kind of metric where what is good enough? How good is good? Is my 15-year-old daughter, is her skills good enough? Is my skills good enough? Whatever that is. And good enough to operate is a subjective call. So it's kind of one that everyone's got different opinions, and I can't come in here and say, look, this is what it is, by goodness. You got to be able to score this and in this time, and that is good enough. I can't do that, but what I can do is I can say, look, here's a big sample of data. Here's a whole bunch of pilots, okay? And the top 10% did this, the top 20% did this, the top 30% did this, and kind of go back off of that. And then acknowledging it's a subjective decision and say, look, what's good enough? Is a B good enough? Well, that's what we did for the academic world, right? So that's where I have lots and lots of students and lots of test data. So we brought them in, and we got, a couple hundred of different, results in, and we said, look, the top 10% performed on the BPERP. They could do those 2 maneuvers in 5 minutes or less, and they got perfect scores. If you can do that, if you're in the top 10, that's an A. And again, we're academics, so we're grading things. That's an A. If you're in the top 20%, that means that you did this test within 6 minutes, you got all the points. Top 20%, you got a B grade. And then same thing, if you did this for, if you were in the top 30% of our sample pool, you did this test within 7 minutes and you got all the points, that's a C grade. All right, so that's what we did for the academic world, right? So students with a little bit of, a good amount hours of training at their age group and their skill, that's what we kind of determined based off of our sample size. But that sample pool is not you guys. You guys are a different pool. You guys are professionals. You have training programs. You are a different sample. So that's where the study is now. And this is one part telling you where we're at, and one part a call for help. What we're doing at Clemson is we're trying to determine for the DOT environment what is good enough. There's lots of things with proficiency, right? There's those 3 different spheres, but we're focusing just on the stick skills. What is good enough for stick skills? And I would not come here and say, by God, Joe Burgett's opinion is this. I'm not going to ever do that. But what I can do, and what we are doing, is collecting data from drone pilots. We're using the simulator, me and my team. That's one. Some of you guys here actually have spoken with the gentleman in here. His name's Colin Dees. He's a PhD student getting his dissertation in this topic. And what he's doing is he's reaching out to DOT pilots, and he's giving them access to the simulator, and he's having them do the BPERP exam, and he's observing them on a Zoom call, asking them some questions, and recording their results. So we're collecting data now on how good DOT pilots are at their stick skills. And when we collect that data, and more data is more data is better, then we can present that to the group and say, look, I'm not going to tell you how good is good enough. But here's where we are now. Here's where the top 10%, 20%, and what do you guys think? What should we use this nationally acceptable, nationally recognized test? If we implement that nationwide, what do you guys think? Where is good? And it might be B, C, or wherever. We'll make that call together, but it'll be data driven. So again, this is my call for help. I mean, you guys may have already been reached out to my lab, or you might be reached out to in future. But if you get an email from Joe Burgett or Colin Dees or something, anything with a Clemson.edu at the end, don't immediately send it to trash. You know, open it up, and if you're willing to participate in the study and have some of your pilots, you know, carve out a half hour, 45 minutes to do the simulator with us, so that we can kind of get that data from them, that'd be very, very appreciated, and I think would benefit this group. So with that, I think we got a couple of minutes for questions. Any thoughts that I could address for you? All right. Well, again, I'm going to give oh, I'm sorry. Yes, sir. Yep. So the question was, is the simulator available to other parties other than the DOTs? And yeah, so the people who house it, the programmers, are Little Arm Studios. They are a for-profit company, so it is available. For purchase. And I want to say a perennial license is maybe $70, and you need a controller, and that's another $70. But again, you can use that over and over again. But yeah. Yeah, so I'm sorry, I misspoke. Yeah, that $70 license is a forever license for an individual level. Or if you're an institution, you can buy individual licenses. They have a boatload of plans. I don't know that I really want to speak for them on that. They probably, if I'm their representative, it's free for everybody. Just ask them. Good question, thank you. Yes, sir. So what I heard from you was that you asked and you didn't get your license. Is that what it was? So the certificates being the BPERP from APSA? What certificates are you referring to? Okay, so the APSA BPERP. Okay, so that's a different organization, and I can get with me. I mean, I don't have any juice with them, but I know some people that can maybe encourage them to get those for you. Did you? I mean, I'm assuming you purchased them from APSA, and you're just now waiting for them. Is that right?
We didn't purchase them. We didn't realize they had to be purchased.
Oh, yeah, that's a key component in the workflow. Yeah, APSA, that's a revenue stream for them. Yeah, is the BPERP, the APSA BPERP certification is something you do have to buy. We can test you as proctors. We can test for it and credential it, but you got to buy it from them. Sorry.
Cool. Thank you.
No. You said that ideally plug in like a DJI or an Altel. There are several different controllers you can use. The Fly Sky, they sell one called the Orca or something, and PlayStation controllers and stuff like that can be used. There are a number of them, but it's not universal. So most drone controllers, like proprietary, like Altels or DJIs, are not compatible with it. All right, thank you guys.